So we have a science advisor. We do a lot of research to make sure that everything that we teach is absolutely true. And we develop this very, very high level sort of content. We have a disproportionate number of students whose parents have PhDs in the sciences who are frequently listening in the background. Sometimes they say that they wish they wouldn't, but they in fact are not able to stop listening in the background, and they report hearing all sorts of really interesting new things that they had never known that just blows their brains before. So I come to this from an outsider who gets to communicate my, holy crap, can you believe that the largest volcano in the world is, sorry, Manisha, do you know what the largest volcano in the world is?
I think it's in the water. Like it doesn't come up high, and so it's surprising. That's what I remember. Is that one of those trivia questions.
Totally correct. And most people will say that it's the big island of Hawaii for that. But it
Mm.
turns out that by any rational calculus, the largest volcano in the world is the Atlantic Ocean.
Wow. Okay, so
And
Brandon,
yeah,
I
sorry.
have a question for you because
Yeah.
I really want to get at this because your approach is very, very different than other approaches to teaching science. How can you define that for people in terms of how science is usually taught and the approach that you're coming from?
We started with the question, if people were to design the 3rd through 8th grade science curriculum, we have some younger kids, we have a bunch of older kids too, but if they started to design that curriculum now, as opposed to the beginning of the 90s, with everything that we know, with like the sort of like gluing together this consilience of all of the different levels of science, how would we make science? And then we don't do the thing where we say like, here's a year of chemistry, here's a year of physics, here's a year of biology, but we take a very serious course in chemistry, physics, and then chemistry, and then anatomy, and then earth science, microbiology, and zoology. Every single year, we take a weird topic for each. We just finished volcanoes, where now we're on to something, apples. And we then try to knit those things together where every topic becomes sort of a portal into the weirdest, most important aspects of modern science through that topic. And then that knits together with everything else. And then all of our lessons are these like hyper interactive, super engaging riddles that I just pose some sort of simple question, like what's the biggest volcano in the world? And then I don't just tell the kids the answer, like I have the kids figure out the answer by giving them clues in the forms of metaphors and stories and weird images and stuff like that.
Yeah, I love your use of the word riddle. It's almost like you're helping shape and transform their processes for thinking.